Hello everyone. In last video we have seen the unit number first, that is electronic components and signal. So up to electronic components we have seen. So now we're going to start with the current and voltage source. So now what is source? As we know that source is a electrical device which supplies electrical energy for the operation of electronic circuit. Source is something, it is the point from which any device or any system is start. Okay, so here the technical definition of source is, it is the electrical device which supplies electrical energy for the operation of electronic circuit. So now in source there is a DC resistance offered by electric source, it's called as internal resistance. This is a term which is important in source, that is DC resistance offered by electric source is called internal resistance. Now here the types of sources are there, that is voltage source, second one is current source. Then in that voltage and current source there are two types, that is ideal voltage source, practical voltage source, ideal current source and practical current source. So now we will see one by one, that is current source. What is current source? The current source are nothing but it is a two terminal circuit element which supplies the same current to any load resistance connected across its terminal. Okay, so current source means what? Two terminal circuit which supplies the same current to any load. कोणत्याही लोडला जे सर्किट करंट सप्लाय करतं त्याला बोलतात करंट सोर्स. Now current source are also categorized in two types, that is ideal and practical, as we have seen earlier. So this is nothing but the we can say current source is denoted by this symbol, this or either this. It is important to keep in mind that the current supplied by the current source is independent of the voltage of the source terminal. Okay, म्हणजे काय, जे व्होल्टेज असतं सोर्स टर्मिनल असतं त्याच्या इंडिपेंडंट असतं करंट सप्लाइड बाय द करंट सोर्स. सो नाव the current source has infinite resistance. Okay, current source has infinite resistance. So these are the characteristics of ideal current source. Okay, this is the voltage or we can say time, or this is our current. Okay, so now in ideal current source, as time goes increases, the current is constant value. Okay, so this is nothing but the characteristics of ideal current source. As we have seen earlier that ideal current source has infinite input resistance. So this is nothing but the characteristics of ideal current source. So now what is practical current source? Practical current source is represented as an ideal current source connected with the resistance in parallel. Okay, जेव्हा आपण प्रॅक्टिकली एखादा सर्किट डिझाईन करतो त्यावेळेला जेव्हा इथे आपण करंट सोर्स कनेक्ट केला त्याच्यानंतर प्रॅक्टिकलमध्ये आपण त्याला एक रेजिस्टर कनेक्ट करतो. सो हे आहे सिम्बॉलिक रिप्रेझेंटेशन ऑफ प्रॅक्टिकल करंट सोर्स. सो नाव दीज आर द कॅरेक्टरिस्टिक्स ऑफ प्रॅक्टिकल करंट सोर्स. Normally what happened, this is the characteristics of ideal current source, and practically we get this type of graph. Means what? As time increases the current goes decreasing slightly. Okay, so this is nothing but our practical current source. So now what is voltage source? As we know that current source is nothing but the circuit which supply the current. So voltage source is a source which supplies electrical energy or voltage. Okay, or we can say the source which supplies electrical energy in the form of voltage. Again, the voltage source is classified into two types, that is DC or AC voltage source. And as compared to current source, the voltage source have zero internal resistance. Okay, so suppose current source have infinite internal resistance, then voltage source have zero internal resistance. This is the symbolic representation of voltage source. Okay, this is the positive line, this is the negative. This is our voltage source, or we can represent as like this type. So this is nothing but your symbolic representation. Then now, what is ideal voltage source? It is a two terminal device which produce a constant voltage. Okay, it produce a constant voltage which does not depend on the load resistance. Okay, लोड रेजिस्टन्सवरती डिपेंड नसतं. जसं जसं तुमचा टाईम इन्क्रीज होईल तसं जसं व्होल्टेज देखील कॉन्स्टंट इन्क्रीज होत जातो, त्याला बोलतात आयडियल व्होल्टेज सोर्स. सो इट इज द सर्किट डायग्राम and characteristics of ideal voltage source. Now this is the practical voltage source. Now this circuit is consist of the voltage source in series with internal resistance. Okay, this is the series connection. So source having some amount of internal resistance are known as practical voltage source. Practical voltage source having some internal resistance value, that's why this graph is decreasing with the increase of time. Okay, voltage is some slightly decreasing than ideal line. So this is nothing but your voltage source and current source. So suppose you might get question that differentiate between current source and voltage source. So first point is your definition. Okay, then second point is current source have infinite internal resistance and voltage source have zero internal resistance. Then third point is the symbolic representation. And fourth point is the characteristics of voltage and current source. So these are the four differentiate point for that question. Then next is, I have put some here, the point is ideal current source. So current source which supplies a constant current to a load even if resistance varies. Okay, even if resistance is varies, the source is supplies constant current. So it is known as constant current source or ideal current source. Means what? If your resistance is varies, the current is constant, it is your ideal. And if your current is slightly decreasing, then it is real. Okay, or practical current source. Now this is the practical current source. Here the resistors is connected and now you can observe that in practical voltage source, okay, so in practical voltage source, this is like, okay, the resistor is connected here in series with the supply, but in practical current source the resistor is connected in parallel with the supply. Okay, so this is the difference between the practical current source and practical voltage source. You have to understand this or remember this. So a practical current source known as real current source is consists of an ideal current source in parallel with a resistance known as internal resistance of the current source. Okay, so this is called internal resistance and this is your supply. So now next is electrical signal. Now what is signal? A signal is a physical quantity that varies with the time, frequency, space or any other dependent or independent quantity. So signal is what? It is a physical quantity that varies with the time. So means what? This is the x-axis. Okay, this is the x-axis. It might be your time, frequency or space, anything, any quantity. Okay. So your signal is vary according to that quantity. So this is nothing but your signal. A signal which represent electrical quantity, either voltage or current, is known as electrical signal. So now electrical signal means what? The signal which represent the electrical quantity, either voltage or current, means what? On y-axis there might be voltage or there might be current. Okay, so it is representing with respect to time or with respect to frequency. So it is known as electrical signal. So now the types of electrical signal. So electrical signals have mainly of two types, that is analog and digital. So now everyone know that we know the analog watch and digital watch. What is the difference between that? In analog watch, yes, so there is a 1 2 3 4 5 like 12 numbers are there. Okay, or you may get one indicator, you may have the time indicators. But in digital signal, digital watch, what happened? We get directly the time. There is no any indicator or there is no any arrow. So that is is nothing but the analog and digital. So what is analog signal and digital signal? So analog signal is a continuous time varying signal. So suppose, so this is your x-axis, this is your y-axis. Okay, it is y, this is x. So a continuous time varying signal which represent a time varying quantity can be termed as analog signal. Suppose your x-axis represent time and y-axis represent your voltage. So analog signal is the continuous time varying signal. Okay, सो जेवढा तुमचा टाइम व्हॅरी होत जाईल तेवढा हा सिग्नल आहे, हा कंटिन्युअस व्हॅरी होत जातो, त्याला बोलतात ॲनालॉग सिग्नल. दिस सिग्नल कीप्स ऑन व्हॅरिंग विथ रिस्पेक्ट टू टाइम. ओके, with respect to time this signal is keep varying according to the instantaneous value of the quantity which represent it. So it is nothing but your analog signal. So now what is digital signal? Digital signal which has only a finite number of distinct value, either 0 or 1. It means what? It is your 1, it is your 0. So this is nothing but a digital signal. Means you just get either 1 or 0. It's like a pulse. Okay. So this is called digital signal. These are discrete in nature or which is non-continuous in form can be termed as digital signal. So analog signal is continuous in form and digital signal is discrete or in non-continuous form. This signal has individual values denoted separately which are not based on the previous value. Okay. So digital signal has individual value. It doesn't depend on the previous value. Means at a particular time it might have different value. This is also a representation of digital signal. Okay. So this is non-continuous in nature. So these are two types of signal. Now what is system response? As you know that if we apply input to any system we get output. Okay, without input we never get any output. So in the system if you give input of something, then only we get the output. So system response is nothing but the internal behavior of the electrical or electronic system. Okay, or we can say dynamic behavior of the system. Now how we study system response? So for that we have to first apply the various signal to the system. Signal means what? Step input, linear input, periodic input. So we just have to apply some types of input. Then depending on the system response for time function and frequency function, the response called time domain system response or frequency domain system response. Okay, so now suppose this is our system, okay, anything. So here is the input and here we get output. So suppose we apply any type of input, that is and we get something at output. Okay, so this process is called system response. So now depending on the system response for time and frequency function, so suppose this is a time function, then at the output we get time domain system response, or if it is frequency function, then at the output we get frequency domain system response. So this is nothing but a system response. So suppose that up now, what is time domain representation? So apply different types of signal and study its system output as a function of time. Time domain representation. So this is your step input. This is your step input, this is ramp input, this is parabolic, and it is impulse. If we apply these inputs to the system, then what type of output we will get? So in time domain representation, if we apply the step input to the system, then for unit step the Laplace representation is 1 upon s. Okay, and for a step input R of s is equal to a upon a. Now what is unit? If your signal is like this, okay, then you will get 1 upon s, or R of s is equal to a upon s. Now for a ramp input, R of s is equal to 1 upon s square. Okay, and for ramp input R of s is equal to a upon s square. It is difference between here unit and here only a for step or for ramp. So this is like for a parabolic input, the unit parabolic input R of s is equal to 1 upon s cube, and here a upon s cube. And for impulse input, for a unit impulse, R of s is equal to 1. So this is the time representation of time domain representation of the signal. Okay, so this is the Laplace transform of common function. Now measuring signal. So this is the analog signal, or we can say waveform. Okay, we can call it as a waveform also. So here you can see that on x-axis there is a time, on y-axis there is a amplitude. Now this is our waveform. This is positive half cycle, it is negative half cycle, and this is called a one half cycle. One cycle, complete cycle. One positive half cycle, one negative half cycle. It completes one cycle. So now these are some terms related to the waveform or our sinusoidal waveform. So first one is cycle. Cycle means what? One complete set of positive and negative values of an alternating current or alternating waveform called cycle. So this is set of positive and negative quantities of alternating current, it called cycle, right? Next one is time period. A time taken by alternating current to complete one cycle is called a time period. ओके, एक कंप्लीट सायकल करण्यासाठी, दिस वन इज कंप्लीट सायकल, ह्या कंप्लीट सायकलसाठी जेवढा टाईम लागतो त्याला बोलतात टाईम पिरियड, विच इज इंडिकेटेड इन टी, इंडिकेटेड बाय टी. सो नाउ व्हॉट इज वोल्टेज? It is the force which moves an electrical current against resistance. Okay, voltage is nothing but our input supply. Then now what is waveform? So waveform is nothing but the shape of signal derived from its amplitude and frequency over a fixed time. So waveform is nothing but the shape of signal. Now earlier we have just seen that this is nothing but the sine wave. Okay, this is sine wave or sinusoidal waveform. So if we see, then this is your step input, right? Then this is your triangular wave. So this called as a waveform. It is nothing but the shape of your signal. So now amplitude. Amplitude is nothing but the maximum value of a signal measured from its average state. So this is nothing but your amplitude, that is maximum value of your signal. So it is the maximum value of your signal, right? So we can call it as a amplitude. Now frequency, the number of cycle produced per second made by alternating current called frequency. So it is the important term that what is frequency. As we know that the positive and negative components of alternating signal is known as one cycle. Okay, so this is your one cycle. So now frequency means what? The number of cycles per second. This is called frequency. So how we calculate the frequency? That is 1 upon time. So frequency means what? 1 upon time म्हणजे 1 upon t, or unit of frequency is hertz. Now one thing is important, that time is reciprocal of frequency. Means what? If they ask for time, then you can write down that 1 upon f. Okay, or if they ask for frequency, then you can write down 1 upon t. So time and frequency are reciprocal to each other. So unit of frequency is hertz and unit of periodic time is second. Now next point is form factor. So form factor is nothing but the ratio of RMS value to the average value of alternating waveform. Okay, so this is the formula for form factor, ratio of RMS value to the average value. Then peak factor, it is the ratio of maximum peak value to the RMS value. This is the formula for peak factor. Or what is average value? It is the mean value of an alternating quantity over one cycle. Average value is nothing but your maximum value, or we can say amplitude. Okay, so these are some terms related to the waveform. You might get asked, or for 2 marks question they might ask what is frequency and amplitude of the sinusoidal signal. So you have to write down the waveform and the definition of these terms. Now integrated circuit. Integrated circuit, you know that ICs. Okay, we can call it as a IC. So what is IC? You might be seeing some IC during your practical session. So it is nothing but it is a miniature or complete electronic circuit consists of active and passive components that are joined together on a single small chip on semiconductor material or insulating substrate. Okay, so this is the technical definition of IC. So it is the miniature or complete electronic circuit consisting of active and passive components that are joined together on single small chip. आपण जे कंपोनंट्स बघितले ॲक्टिव्ह अँड पॅसिव्ह, जे एका स्मॉल चिपवरती जॉईन केलेले असतात, सो त्याला बोलतो आपण आय सी. सो इंटिग्रेटेड सर्किट और आय सी इट इज समटाइम कॉल्ड चिप और मायक्रो चिप. मायक्रोचिप कशासाठी, कारण ती खूपच लहान असते म्हणून मायक्रोचिप. इट इज अ सेमीकंडक्टर वेफर ऑन विच 1000 or millions ऑफ रेजिस्टर, कपॅसिटर अँड ट्रान्झिस्टर आर फॅब्रिकेटेड. ओके, खूप छोटी चिप असते, त्याच्यावरती 1000 millions ऑफ टायनी रेजिस्टर म्हणजे छोटे छोटे रेजिस्टर, कपॅसिटर, ट्रान्झिस्टर फॅब्रिकेट केलेले असतात. नाव रिमेंबर वन थिंग, दॅट आय सीवरती इंडक्टर कधीही फॅब्रिकेट केलेले नसतात. सो इथे जर बघितलं तर मी फक्त रेजिस्टर आणि कपॅसिटर टाकले, सो इंडक्टर कधीही फॅब्रिकेट होत नाहीत. ओके, तर रेजिस्टर, कपॅसिटर अँड ट्रान्झिस्टर. IC can be function as amplifier, oscillator, timer. Okay, so these are the application of IC. Means you may have oscillator IC, amplifier IC, timer IC, counter IC. Okay, so these are some applications. So this is the nothing but the definition of integrated circuit. So now what is scale or level in integrated circuit? Okay, so there are various scale, or we can say levels of IC. So how can we decide that this is the scale? So how much number of electronics components are fabricated on that chip, म्हणजे त्या एका चिपवरती किती इलेक्ट्रॉनिक्स कंपोनंट फॅब्रिकेट केलेले आहेत त्याच्यावरून त्या आय सीची स्केल ठरवली जाते. ओके, सो अकॉर्डिंग टू दिस देर आर 4 to 5 टाइप्स ऑफ scales are there. That is, first one is SSI. SSI is nothing but small scale integration. Okay, so we can say that small scale integration technology. So in which the number of circuit contained in single IC package. Okay, so एका IC package मध्ये किती सर्किट असतात, तर ते लेस दॅन 30 और components किती, components are less than 50. so this is nothing but small scales, म्हणजे जी कंपोनंट्सची किंवा आय सी पॅकेजेसचे नंबर्स आहेत ते स्मॉल आहेत. देन सेकंड वन इज MSI, that is medium scale integration technology. So in this the number of circuit contained in one IC package is 30. म्हणजे एका आय सी पॅकेजवरती 30 सर्किट्स, 30 to 100 सर्किट्स असू शकतात, आणि नंबर ऑफ कंपोनंट किती असतील त्याच्यामध्ये, तर इन बिटवीन 50 to 500. ओके, सो दिस इज मीडियम स्केल इंटिग्रेशन. नाउ थर्ड वन इज लार्ज स्केल इंटिग्रेशन. इन लार्ज स्केल इंटिग्रेशन द नंबर ऑफ सर्किट्स in that one IC package is between 100 to 10,000 and the number of components are between 500 to 30,000. ओके, सो एवढे कंपोनंट असतात ते त्याच्यावरती फॅब्रिकेट केलेले असतात. सो दिस इज लार्ज स्केल. देन फोर्थ वन इज VLSI. सो VLSI इज व्हेरी लार्ज स्केल इंटिग्रेशन. Okay, so in very large scale integration the number of circuit contained in one IC package is greater than 10,000 and number of components is greater than 30,000. So now also there is one also ULSI is there, that is ultra large scale integration. So in that the number of components and circuits are in the range of millions, billions. Okay, so this is the scales of ICs, okay, which is depends on total number of electronic component fabricated on that chip. Okay, clear? So now some advantages of ICs. Why we use IC, why these are important to us in our electronic world. So the main first thing is the size is extremely strong. Also, although they have millions or billions of components on that single chip, but the size of chip is very small. Okay, so this is the first advantage. Then as the size is small, weight is also very less as compared to the other circuit. Okay, then they are highly reliable due to elimination of soldering. So suppose you design PCB, then you might have idea that there is a soldering, and because of that soldering the circuit is become so complicated, or so here is the advantage is that highly reliable. Then fourth one is less power consumption. Fifth one is high performance. and next is easy to replace. So there are lots of advantages. So these are some important advantages. Okay, then these are some disadvantages. So disadvantages, as I earlier said, that the inductor cannot be fabricated. Okay, in IC we fabricate resistor, capacitor, but not inductor. Not possible to fabricate high grade PNP unit. Okay, high grade PNP unit F. It is not possible to fabricate high grade PNP unit. It is not possible to fabricate capacitor or resistor exceeding values of 30 picofarad and 100 kilo ohm respectively. Okay, so IC वरती 30 पिकोफॅरेडच्या वरती आपण कॅपॅसिटर फॅब्रिकेट करू शकत नाही आणि 100 किलो ओमच्या व्हॅल्यूच्या वरती जर एक्सीड होत असेल रेजिस्टरची व्हॅल्यू तर आपण ते फॅब्रिकेट करू शकत नाही. देन पॉवर डिसिपिएशन इज लिमिटेड. दिस इज ऑल्सो वन डिसएडवांटेजेस. Then also transistor have large saturation resistance. So these are some disadvantages point of IC. So now this is some extra point, that is IC is having of two types, that is analog ICs and digital IC. Okay, so analog means what? The analog integrated circuit work by tackling continuous signal and are capable of performing tasks such as filtering, amplification, demodulation, modulation, etc. Okay, so analog ICs म्हणजे काय? These are works on a analog signal. Analog signal means what? These are works on a continuous signal. Okay, so that's why we can call it as an analog integrated IC, and they are used to perform the task, like they are used in filtering process, amplification, demodulation, modulation process, etc. Okay, so ह्या ॲनालॉग प्रोसेसमध्ये ते यूज होतात. आणि त्यांची ॲप्लिकेशन कुठली आहे? सेन्सर्समध्ये, ओपॅम्प. दीज आर सम ॲनालॉग ICs. ओके, दीज आर सम एक्झाम्पल ऑफ ॲनालॉग IC. So linear IC, RF ICs are analog ICs. Then digital ICs. So as we know that what is digital, so they have some only, the signal is represented only one or zeros form. Okay, so which is implies that they work on a binary mathematics only, that is 0 and 1. 1 is nothing for on and 0 is for off purpose. So in digital you heard that logic gates, then flip-flops. So these are some examples of digital circuits or digital ICs. Then application of integrated circuit. At the same, they are used in radar, then televisions, PCs, video processor, amplifiers, filters, logic devices, radio frequency encoder decoders, then modulator demodulators. So these are some application of integrated circuits. Thank you. If you have any doubts, then please comment in comment box. Thank you so much, and please don't forget to subscribe my channel. Thank you so much.